Good morning, Brisbane. Good morning, all. It is great to be here today, and I'm excited to share with you on what MRT has achieved in this space. Before I start my presentation, allow me to play a short video before I start. Enjoy.
With over 1.7 million people residing in just 94 square kilometers, Kuala Lumpur has one of the highest population densities globally. However, rapid urbanization is resulting in a significant challenge to livability in the region. Beyond connecting citizens and visitors in the Klang Valley region, Malaysia's Mass Rapid Transit Corporation, or MRTC, is helping transform Kuala Lumpur into a green city. Construction of its Klang Valley Mass Rapid Transit project will contribute to a rail-based public transport network within the capital city, as well as new sustainable park and ride facilities and public amenities.
KV MRT system is providing a major boost in the integration and efficiency of urban public transport.
The country's largest infrastructure project is already having a significant economic impact in Malaysia and within the region. As the first metro project in Asia Pacific to ensure greater collaboration and efficiency across teams with building information modeling, or BIM, methodologies, the SSP line is expected to be delivered on schedule and on budget. Taking advantage of digital technologies for its SSP line, MRTC is improving connectivity for local and regional businesses, expanding workforce skills, attracting international investment, and increasing property values across the Klang Valley region. Digital transformation is helping transform the lives of millions of Malaysians today in preparation for a better tomorrow.
Earlier this week, I got a chance to meet some of key Queensland government agencies, and I'm really impressed to learn that there's a lot of opportunity for Brisbane for infrastructure development. As one of Australia's fastest growing cities, there are parallels between Brisbane and Kuala Lumpur, notwithstanding in the population and also population density, of course. So, Brisbane have around 2 million people spreading in 6,000 square kilometers, while KL has 6 million people, around 2,800 square kilometers. So I have come today to share with you on the story behind Kuala Lumpur Mass Rapid Transit project, and also to take you behind the scene of what media has dubbed Asia's most ambitious engineering project, and to show you on details on how MRT Corp has embraced digital engineering in the MRT Sungai Buloh Sedang Putrajaya project. It is all started back in 2010, where the Malaysian government has the vision to create a new economic region, which is called Greater Kuala Lumpur. This economic region is designed for the massive income spillover that will positively impact our gross national income. Vision 2020, that is the government vision to create for the Greater Kuala Lumpur. The first 20 is to turn Greater Kuala Lumpur to become top 20 most livable city in the world, and the second 20 is to become top 20 economic cities in the world. As the economic grows, the population is also expected to increase. And that will be hit more than 10 million by 2020. This increase will create a high demand for efficiencies, dynamic intra-city public transport system. To address the future demand for mobility in Greater Kuala Lumpur, a 3-line mass rapid transit system has been planned, and it will comprise of 2 northwest-southeast radial lines and 1 circle line looping around Kuala Lumpur. This project is called Klang Valley Mass Rapid Transit. The government then set up Mass Rapid Transit Corporation, a special purpose vehicle under Ministry of Finance Incorporated, Malaysia, to become the developer and the asset owner of the KV MRT system. We are responsible for all planning, development, and the construction of KV MRT infrastructures and assets. Shown here is the entire KV MRT alignment for both MRT Line 1 and MRT Line 2. The MRT Line 1, or SBK, is displayed in green, was opened to public in July 2017, and the MRT Line 2, or SSP line, displayed in red, is currently under construction and due for completion by July 2022. This is the conceptual alignment for our 3rd line, the MRT Circle Line. The project was due to start mid-2018 and completed by 2022, but it was put in hold in view of the current government financial standing. The entire alignment of the SSP line is 52.2 kilometers, and this consists of 13.5 underground tracks and 38.7 elevated tracks. It will serve a corridor of population around 2 million from Putrajaya to Sungai Buloh. The MRT line will have 35 stations, where 24 are elevated and 11 are underground. The picture shown here is the rolling stock which was awarded to Hyundai Rotem from South Korea. This rolling stock will include 58 4-car driverless electric train, which can carry up to 1,200 passengers at one time. This is the architect impression of the MRT SSP line elevated station. The elevated station architecture was inspired by the concept of Serambi at the village house or longhouse. This concept provides open ventilation, natural lighting, and also natural visual effect via play of light and shadow. The SSP alignment will start from the existing Sungai Buloh depot and will pass through the residential area in the northwest of Klang Valley. Then it will pass through few suburbs, mainly residential areas. Once it reaches the city center, the train will start going underground from North Portal, going to major commercial area, including Petronas Twin Tower, and back to the elevated alignment at the South Portal. The line will continue to southeast of Klang Valley, which will pass through other suburbs, mainly residential area, universities, our second depot, commercial area, residential area, and our IT park, which is Cyberjaya, before terminating at Putrajaya, our government administrative center. The overall progress has reached 64%, and this project will be operated in 2 phases. Phase 1 will be operated in July 2021, and full operation will be by July 2022. This is our proud moment earlier this year when we have reached first milestone of the tunnel boring machine breakthrough at one of our stations. These are some photographs of our construction progress. These are some of photographs of our elevated and system progress. We target to complete civil work activities, mainly for piers and viaduct construction, completion by year end. And this is the final two completely built up electric trains that we have received from Hyundai Rotem at our depot. Next, I would like to share some of the challenges that we have in our project team and how digital engineering has become a great help to overcome all these challenges. The MRT SSP line consists of over 1,000 multidisciplinary professionals like architects, engineers, planners, geologists, and controllers. These people are the heart of MRT SSP line project, and they are responsible to deliver the project within time, within budget, to the government of Malaysia. Our work involved in the design and the construction of the SSP line project. These include underground station, elevated guideway, depot, tunnels, as well as the electrical and mechanical system required to fully complete a fully functional railway system. It is very important for us to ensure the information available across the project, it is accurate, up to date, and no misinterpretation between stakeholders. We need to ensure the design information, as-built, and as-built validation has been managed and been kept within the project, as the MRT structures will have a long lifespan, which is over 100 years. Next is the technical complexity of the design. This illustration shows on how complex it is to design and construct the MRT station. This involves cross-functional and multidiscipline fields within a tight schedule. The engineering design information need to be organized systematically and in structured way so that it is easy to retrieve. The attributes need to be updated correctly according to the project classification. To overcome these challenges, MRT Corp has embarked on digital transformation program for the design and the construction of the project. This main objective of the digital transformation program is to improve the project productivity by 35%. And in order for us to achieve this, we are pushing 6 digital engineering initiatives into our project. We are mandating the use of BIM Level 2 framework for our underground and system work, contractor to carry out design and also construction in the common data environment following BS 1192 standard. We developed GIS web portal to host all our design and engineering information utilities as built and construction model. We also utilize reality model drone for site progress and monitoring. We also use 3D laser scanner for build model validation and verification. Together with our contractors, we are pushing paperless, mainly for the inspection, dashboard reporting, and progress update. Finally, we're also pushing the mobile app for the digitalization of the construction forms, permit, and approval at site by our contractors. Next, I would like to showcase some of our work on how we have applied digital engineering in the design and the construction of the MRT SSP line project. The MRT station is one of the stations located in the city. So this is the station, future station that we are going to build. And this is the existing station. This monorail service and LRT Titiwangsa service is already there. So the future MRT station is intended to be an interchange station that will be integrated seamlessly with these two stations. Now, I would like to share on how GIS has been used in this program. For this project, our geospatial portal is using ArcGIS Enterprise. We are currently compiling all engineering drawing, spatial information, document, and record into a centralized mapping viewer. This video shows a collection of soil investigation boreholes that we have converted from AGS4 format from our geotechnical team. The AGS4 is a text-based format, and it contains all detailed information about soil profile. For us to bring this data into GIS, we have developed a spatial conversion tools, and now the geotech engineer will have the ability to see the borehole reports together with the visual representation. We also create a widget to highlight the depth of the soil type for each boreholes. It will provide a graphical representation of the soil depth. Here is the video showing few boreholes in customized widget viewer that highlight soil profile and soil depth. In addition to the compilation and also the presentation, we also have developed an API and interface with leading geosystem and tunneling software. The purpose of this API is to map the tunnel progress every day into our GIS portal. This information, like tunnel position and ring progress, are being tracked daily in our GIS portal. So you can see their progress that has been made by our tunnel TBM mission from this location. For this project, we have moved from on-premise server to cloud-based server implementation, which provide better reliability and availability of our project data. We are adopting Microsoft Azure Clouds for both GIS production and development server. These servers are fully interfaced with KVMRT CDE, and we are also replicating both server in cloud and on-premise to backup and to protect our project data. We are also proud that we are the first project in Asia region to have ArcGIS Server Enterprise on full cloud configuration deployment. Next, I'm going to share things that keep us busy every day, fusing GIS data with BIM and reality model for this project. The SSP line is one of the first in Asia region and among a very few in the world to implement BIM level 2 for an infrastructure of this scale and complexity. This model demonstrates the station design complexity in 3D, and it allows our engineers to visualize, to collaborate, and to analyze every aspect of engineering in virtual world for design and construction process. To help our engineer retrieving the Titiwangsa model quicker, faster, and intuitive, we have interfaced our GIS portal with project CDE infrastructure directly on cloud. Engineers can retrieve this model directly from the map viewer using a simplified interface pop-ups and attribute link directly to the model using ArcGIS Pro. We are also pushing the boundaries and setting up benchmark in various aspects of the project development. Among them is the use of the reality model. The reality model are being used by our engineers to review the current progress at site, conduct visual inspection, perform measurement, and review stockpile volume. what you see here is the reality model of Titi Wangsa Station and the detail of the construction progress. We have monthly program to capture reality model for all our underground site. The scene layer output in Esri i3s format are being reviewed, compared, and fused with BIM model in ArcGIS Pro before we publish the model in unified into 3D scene viewer. This video shows the monthly routine by our GIS engineer reviewing the current construction progress using BIM model and latest reality model in ArcGIS Pro. Once the 3D model ready, we are able to fuse this model as one unified before publishing into Esri 3D web scene. We are also utilize 3D laser scanning mainly for as-built. This technology allows our engineers to find out the detailed structures of the viaducts, height clearance, and structure type. We also host the unified model into our GIS portal for our project team to see the site progress virtually on cloud. The 3D web scene viewer able to fuse multi-type of information such as street map, aerial photography, 3D model, and reality model into a unified 3D viewer. Our project team are heavily using this information from site office and the design office to understand site context, review site progress, and inspect any site incidents. In this video, you will see all engineering design are from BIM model that are being published into 3D web scene viewer. The BIM model are architecture model, structure model, and later you can see the tunnel model. And all these models are very detailed and complex. Not just model, we are also bringing the attribute and also the classification from BIM model into this viewer. This attribute will help our project team to understand the full context of their review. So if you can see here, this is the attribute that we have bring from the BIM model. Our journey is not ending here. We are continuously harnessing the ArcGIS technology for our corporate GIS application. We are developing comprehensive GIS database for our development and building control, which will contain all MRT SBK line design information, engineering drawing, and electronic plans. We are also testing collector and Survey 123 app for our field mapping and data capture tool for our engineers to monitor encroachment, zone violation, and illegal activity in our protection zone. We are also developing land management database using ArcGIS Online for our land management team to capture all land-related information, valuation, legal record, correspondence, and financial data. And finally, we are also looking at ArcGIS Analytics to understand our feeder bus, ridership patterns and trends, and later address our last mile connection issues. We are also recently trialing augmented reality using our BIM data. And here is the video showing the progress. The augmented reality was developed using BIM data and gaming engine. Once the engineer are able to geotagging the site location, this model can be loaded using a tablet on site. We have found a few use cases for using augmented reality for the construction project. Among them, the AR will be able to use for the space coordination and confirmation. The AR also able to use at a job site with a live walkthrough. And finally, we also can communicate any discrepancies during the construction activity with the other teams. Now, we have end to the presentation. I hope you have learned something new today on how MRT Corp has utilized digital engineering in the SSP line project. I thank you for your attention, and I look forward all of you on board of MRT train soon in Kuala Lumpur. Cheers.